Hi everyone and welcome back to Matter for Thought. Today I have the honor to have here a fellow glowhead. WheresWally? It's a pleasure to have you here.
After we saw in the previous episode what a function is, in this episode we continue with motion, and this time motion at a varying velocity. The velocity can vary in a lot of different ways, and we will get to the vast majority of them as the series progresses. But this time we will talk about velocity that is changing at a steady rate. When we have an object whose velocity changes at a steady pace, we can actually say that the velocity vector changes over time. And just like with the position vector, when this is divided by time, we get a velocity vector. When we divide the velocity vector by time, we get the change of velocity, or in other words, acceleration. The formula or function of velocity in motion at a constant acceleration is v by t equals v0 plus at, the exact pattern of the position vector at a constant velocity. At present, we will assume that there are no additional constraints and factors to understand the principles of what the position vector of an object that accelerates at a uniform rate looks like. To calculate that, we will use the formula for calculating the sum of an arithmetic progression. For those of you who do not remember, let's present it on the board. An arithmetic progression is a series of numbers whose difference is constant. For example, 1, 2, 3, or 5, 10, 15, so on. The sum of the series is the first number plus the last number multiplied by the amount of numbers in the series and divided by 2. Therefore, the smallest number is equivalent to the initial position r0, height of the first column is equal to the initial velocity v0, and the change of the height between the columns is the acceleration. Therefore, the function obtained for calculating the position vector of motion at a constant rate of acceleration is rt equals r0 plus v0t plus a half at squared. So let's go back to our 2D axis system and see what it looks like. This time the x-axis represents time and the y-axis represents location. Suppose we are dealing here with a missile that starts at rest and increases its speed by 1 meter per second every second and moves upwards. So at time 0 the position is the ground, i.e. altitude 0, and the velocity is 0 because it's still at rest. At time 1 the velocity is 1 meter per second and the position is 1 squared over 2, i.e. half a meter above the ground. At time 2, the velocity is 2 and the position is 2 meters above the ground. At time 3, the velocity is 3 and the height is 4.5 meters above the ground, and so on. In the next episode, we'll get to know another concept and talk about motion in two axes, where one axis is with acceleration and the other axis without.
Thank you very much. I'm looking forward to see you here more. And that's for today, friends. I know this topic is a little complicated, but I hope I made it clear enough. Before I wrap things up, I want to thank my patrons. If you find the content good, a link to my Patreon is in the description. Feel free to like and share, subscribe to the channel, and please leave a comment. I was, as always, rndthinker, and see you in the next video.